Recording in progress.
So let's try the code part, right? Can we try that? Can we try? Tell me that. Yesterday we have, I hope all of you are having the understanding how to actually imagine that, how to separate the sorted and unsorted zone and try the searching on here, right? Okay, fine. Let's try the code part. Just let me, where is the reset part here? Okay, fine. This is it. Let's have an array. And this array would be representing the sorted rotated array, right? How that should be looking like a sorted rotated array? Give me an example as per your thought process. Sorted rotated array. How that should be looking like? Give me an example. Let that
7, 8,
yeah, 5, 7, 8, let's say 9,
9,
let's say, and 2, 3,
2, 3, 4.
4, right? Sorted rotated array, we have taken two sorted segments, 5, 7, 9, 2, 3, 4. Let's suppose what we are searching for. Any number you suggest that we are searching for right now? Let that be 7, let's say. Okay. Okay, then what should I do from here? I know that initially I can start off my search from the 0th index. Let's have the size of my array. Let's have the size of my array. That's going to be equal to that of array of length. And initially the search space in between the 0th index till the index n minus 1. Correct? Am I correct onto that part? Till what point we can keep on searching till the time there is at least an element into my search zone, till the time start is lesser than equal to end. Then what should I do? Tell me that. Then from here, what should I do?
Find the middle.
Initially find the middle. And that's gonna be equal to that of, we can simply take start plus n divided by 2, correct? Okay, this part is done. First case, what should I handle for searching into the sorted rotated array?
Check
If
mid element equal to target.
If array of mid, right, is equal to that of the required element k. Fine, then I just say, sorry, I'm just gonna say that fine, okay, we can do one thing, we can keep at what index that is present, that is let it be -1 initially. That means by default I'm assuming the element may not be present. Okay, if it is found somewhere, then I'm gonna just say I'm gonna assign that particular index to the variable whatever I'm keeping as my answer, and then I'm gonna break the loop here, correct? So what should I say is that if at the mid index the element k has been found, then I'm gonna just say index would be equal to that of the current mid wherever the right now searching is going on, and then I'm gonna break out from here, right? Okay, what else? If this is not the scenario, at the mid index, definitely I am unable to find the the current element k, whatever I'm searching for. Then what should I do from here?
Check the start and mid index is a sorted array or unsorted one.
Definitely. So I have to check, right? In between start to the mid, whether that's a sorted or unsorted zone, that I have to check. All of you agree with me here? This is what we have seen yesterday. This is what we have seen yesterday. Am I correct or am I wrong? Tell me. Am I correct or am I wrong? Suppose that you are having the array like this, say 5, 6, 7, 8, 2, 3, 4, correct? Now the fact is that, let's say you are having, let's remove this 4 from here. 5, 6, 7, 2, 3. Let us suppose this is my given array. Then what's gonna happen? My mid would be pointing here, I feel, correct? From start to the mid and from mid plus 1 to the end. I think this is going unsorted, this is going sorted, right? So I'm gonna say for one thing, first I'm gonna check whether the first region in between start to the mid, whether that's sorted or not. How to check that? In terms of a sorted rotated array, the first region is sorted. How to check that? Can anyone tell? So that's
Start
simple.
then mid.
If array of start is lesser than equal to array of mid, correct? If this scenario is getting maintained, then definitely all the elements in between start to the mid are in an increasing order. The given array is sorted rotated for sure. Then only I can try taking a call like this. For any random array, I cannot take a call like this, right? Because there may not be any increasing or decreasing order maintained. Fine. Then what should I do? Then what should I do? Just give me a minute. Okay, so let's begin. And if suppose this region is sorted, that means from start to the mid, there is an increasing order that has been maintained. Then what should I do? How can I take a call that in between start to the mid, I have to keep on searching? Tell me that. How can I take the call? If this is
Check
the
mid less
this
than
thing is,
start.
I can keep a comment, right? Start to the mid. If this region is sorted, okay, then I have to check that within the range of elements start to the mid, the element k is falling within this range of elements or not. Correct? That's what I have to check. How to do it? Check for one thing. If suppose k is greater than equal to array of start, am I correct? And what is this? And what next should I do? K is lesser than equal to array of mid. If within the range of elements k is also falling, then what should I do? Then what should I do? Then what should I do? Tell me.
N equal to mid minus 1.
Yeah, I have to just shift. I can just keep on searching into the region, right? I know that. Suppose I'm searching for 7, or let's say I'm searching for 6, as per the example I have taken. Then I'm searching for the first region, whether that's sorted or not. Okay, so I found that 5 is lesser than equal to 7. So all the elements in between 5 to 7, they are increasing in nature. That's what I have found out with respect to a sorted rotated array, correct? Fine. Now, one thing is that, let's suppose I'm searching for 6, then I can just try taking a call whether to keep on searching into the region or not. So I have to check whether 6 is greater than equal to 5 or not, 6 is lesser than equal to 7 or not. If into the region of elements that starts up with 5, ends with 7, 6 is falling into the range, I'm gonna keep on searching here, right? I already know that mid element is not equal to that of my element k. Had it been so, the loop would have broken in the above lines of code, right? So I should do what here? I should do for one thing. If the element k is residing in between array of start to the mid, then definitely I should say that end will be shifted to mid minus 1. Keep on searching into the same region. Keep on searching into the same region from start to mid minus 1, because I'm sure that from mid to end, right, the element is not residing. Okay. Else, suppose that this scenario is not correct. Even if the current region in between start to the mid, if this is sorted, let's say, even if it is sorted, then, but still, I say you that you are searching for 2, let's say. You are searching for 2, let's say. You are searching for 2, then 2 does not reside within this range of elements. I have to keep on searching towards the right. I know that this is sorted, but within this range of elements, 2 does not reside. So I have to keep on searching towards the righter zone of elements. Am I correct onto that part? So what should I do? I should shift that. That fine. If the region in between start to the mid, if this is sorted, but in this region element does not reside, then what should I do? I should shift my start to mid plus 1. This part is done, right? Okay, suppose that this region is not sorted at all. Then what should I do? Can be true, right? This region is not sorted at all. You might be having an array like this. You might be having an array like this, 5, 6, 1, 2, 3, 4, let's say, correct? Then in this region is not sorted at all. So I cannot directly take any conclusion from here. I have to check the next part that is sorted in nature, right? I have to check the next part that is sorted in nature. So I can keep an else block for this. If this region is not sorted 100%, the next region is going to be sorted for us. Correct? That's the nature of your sorted rotated arrays. Fine. Okay, then what should I do? What should I do? Check whether in this region, the second region is sorted for us right now inside the block of code, whatever we are handling. Okay, then what should I do? Tell me. If the writer region is sorted, right? Then I have to keep a check here. How to check this region that the element k is residing here or not? Can anyone tell?
If ARR of mid greater than or equal to k.
If ARR of mid plus 1, right?
Yeah.
That's the writer region for us. If ARR of mid plus 1, that is greater than equal to
K.
K.
And
sorry, I think this is not the case. If k is greater than equal to ARR of mid plus 1, ARR of mid plus 1 is the smallest element into the region. So k should be greater than equal to that, and k should be lesser than equal to ARR of end, right?
Yes.
Fine. If this is the scenario, keep on searching into the region. Keep on searching into the region. You just shift your start to mid plus 1, correct? that I have to go on and keep my search to the right region. But if it is not so, even though the second region is sorted, my element k does not reside here, I have to keep on searching towards the left region. So I should say that else what to do? Else you do what? Else you just shift to your end to mid -1. That's it. That's it. Fine. And at the end, wherever whatever is the final value of my index that I got, I'm gonna print it. That at this particular index, my element k is residing, right? Let me try running it. One. Okay, so at index 1, whatever we were searching for 7, am I correct? Whatever we were searching for 7, so that resides in index 1. That's fine. Okay. Any other element we wish to search for? Any other element? Suppose that you are searching for 4, let's say, correct? You are searching for 4. It resides at index 6. Is it coming good? 0, 1, 2, 3, 4, 5, 6. Yeah. Suppose that you are searching for 2. Are we able to find that element? Let's see that. Yeah, so that's going to be 4. In element 2 is residing at index 4. Fine. Okay. There is a corner case that we are not handling here. Can anyone tell me about that a little bit? Okay, fine. Is there any corner case that we are leaving here? What are your thoughts onto that? No, I feel everything is being covered here. Okay. One question that may come to your mind is that you are trying to access mid +1 here. Am I correct? You're trying to access mid +1 here. What if you are having just a single element, that is 4? This is the last search space that is left to me. And start, end, and mid all are pointing to the same element only. Then is this a valid access, whatever we are getting? What are your thoughts? Is my code prone to give me segmentation fault or runtime error?
No, it won't happen.
Anyone?
Mid should be less than or equal to end anyway.
No, it can happen, right? For more than one element, suppose that 1 and 2 you are having inside the search space, then there is a valid mid +1. Start and mid both point to the first element, mid +1 and end both point to the second element. There is a valid mid +1. My point is, when the search space is getting reduced to just a single element, there is a block of code where I am trying to still access mid +1. But here, corresponding to this particular region, there is no valid mid +1 index. Mid is pointing to the index 0, let's say. Let's assume that into my array there is just a single element. If I try to access mid +1, then it's gonna go and try access the nth index, which does not exist. Then what will happen?
Suppose we have one element now, it will go into first if statement, right?
Exactly. Right. If we are just left with a single element, right? This element, whatever element you are having, this is already sorted for us, correct? A particular region, whatever I am having, right? If that is having just a single element X, this region is already sorted. All of you agree with me? Element with a just single element is already sorted. Fine. Then what should I do? I can just try checking. The first case would be whether this element, whatever I'm left with, whether this is equal to that of k or not. If it is so, I'm going to assign my index to the mid value and I'm going to break. Else, the flow would be first coming here and this condition is going to be true. Right? Array of start and mid both are pointing to the same element only. So the condition is true. Array of start is lesser than equal to array of mid. That means I'm assuming this region of single element is sorted. And I'm going to just check here. What is that? If k is greater than equal to array of start, k is lesser than equal to array of mid. So basically k is going to get compared to the same element, the only element that we are left with. If it is so, I'm going to shift my end or I'm going to just shift my start. Anyhow, any of the case would be executed and the region will extinct. Beyond that, no further searching would be possible. Okay, because here either of the case would be executed, right? And into the X, start is also residing here, end is also residing here, mid is also residing here, right? On the same element only. If I just say that whatever is the kth element is satisfying this criteria, then it's gonna say me that fine, do for one thing, end is equal to mid -1, then end would be shifted to one step back of the start. End would be shifted to one step back of the start, and that's gonna indicate that start has gone greater than end. So my search space has extincted, no more searching would be there, or else start would be going to mid plus one. Start would be going one step ahead, correct? Start would be going one step ahead. Again, the same condition would be signified. Definitely afterwards, after particular this step, there would be no more searching. So our algorithm, whatever we are employing, it's perfectly fine. There is no problem into it. Okay, repeated division of the region into halves based on the current mid. Wherever I'm standing, I am either going to the lefter half or the righter half for my searching, right? So again, if for the sorted rotated array, you can apply binary search and you can search for the given element, whether that's present into the sorted rotated array or not, in just login time. Okay, into just login time, not more than that. I'm just doing repeated searches as discussed yesterday as well. I feel that you are keep on dividing the region into halves, and at the end you are just left with a single element to be searched for, right? So in total we are searching log n times, not more than that. That's it. Okay, is the code part clear to everyone? How to go ahead for the sorted rotated array? Tell me, all of you. Tell me, all of you, is the code part clear? Is the coding part clear to everyone? Can we move on then? All of you can do it. All of you can do it after the class. Hello. Am I audible? Am I audible or not? All
Yes,
of
you
you
are audible.
from here. Okay, so I think Sudhakaran has already done that. Please go through the code and go through the video once more and try to implement that, right? Okay, fine. Let's have a quick variation of the problem. Suppose that you are given a sorted rotated array, something like this. 5, 6 is there, and 2, 3, 4, 5. Okay, 2, 3. Or let's take it to be 1, 2, 3, 4, by the way. If suppose I ask you, find the greatest element into the sorted rotated array, then how you are going to go ahead with that? Find the greatest element into the sorted rotated array. How you're gonna do that? Definitely that's a sorted rotated. It has been rotated sometimes and it was previously sorted. That's guaranteed. Now my point is, take out the greatest element from here. How you're gonna go ahead? What is the greatest element? Can you try bringing on any observation? That what is the greatest element, and corresponding to the greatest element, what is happening?
6 is the greatest element.
Okay, and after 6, a new sorted segment is starting. Am I correct? After 6, a new sorted segment is starting off. Am I correct onto that part?
Yes.
Whenever I hit 6, afterwards a new sorted segment starts, right? 6 is the breakpoint for us. Am I correct? 6 is the breakpoint for us. Till 6, everything increases from the beginning. Am I correct? All of you agree with me? From the start of the array till the maximum element, everything would be increasing. And post that, again, there would be an increasing trend starting from the minimum element. Is it the same thing what we are observing? After 6, the minimum element of the array resides. Tell me. After the maximum element, since it has been sorted, rotated, the minimum element resides. And again, from the minimum element, you show a rising trend, right? You show a rising trend. Tell me for one thing right now, in what region? Suppose that I'm telling you 5, 6, 1, 2, 3, 4. I'm saying that, okay, my mid is pointing here, my start is pointing here, my end is pointing here. Correct? Now tell me for one thing, in what region I can take a call that in what region would be my greatest element of the sorted rotated array would be residing?
First region.
Into the unsorted region. Am I correct?
Yes.
It has to be the unsorted region, because why it is unsorted, by the way? Why it is unsorted? From the beginning, we came to the maximum element, and then again, it showed a decreasing trend, and from here it again showed a increasing trend. Am I correct? So that's why, due to the breakpoint on the maximum element, right, the entire region turned out to be an unsorted zone. All of you agree with me here? All of you agree with me here? So whenever I'm getting a case that my array is getting divided into two scenarios, one is sorted, another is unsorted, then definitely into the unsorted zone, the unsorted nature is arising due to the maximum element breakpoint area. All of you got it? All of you got the approach? Fine. So let's keep on searching towards the unsorted region, what has been just formed, right? So I'm going to say that 561. This is the unsorted zone, what I have to keep searching on for. Fine. Then start points here, end points here, and mid points here as well. Then what should I do from here? Tell me. What should I do? Able to see one thing, that start to the mid is also sorted, mid to the end, this is also sorted. Can I say that whenever this scenario is arising, that both the regions, whatever I'm left to search for, both are coming to be sorted, then whatever is my mid, that is the maximum element. Tell me that. Tell me that. Is it going good? I right now came to such a situation, whatever are the leftover elements into the region to be searched for, right? From start to the mid, I got a sorted region. From mid plus 1 to the end, I got another sorted region. So wherever the current mid is pointing, right, that is the maximum element. In other words, this maximum element is that region, right? This maximum element is that region from the start that divides both the arrays into two sorted zones. So whenever my mid will be pointing to this max element, from start to the max, whatever is my leftover elements to be searched for, from start to the max, this will also be sorted. From mid plus 1 to the end, this will also be sorted. So whenever I arrive at this particular situation, the mid element, right, the mid index, wherever I'm standing at, that is pointing to the max element of the sorted rotated array. Let's take another example. Let this be 1, 2, 3, 4, 5, let's say, and then, okay, fine. Let's have something like this: 7, 8, 9, 10, 11, 12, and let's say 4, 5. This is the overall array you are having, correct? Okay, then this is start and this is end. From start to the end, we are having these set of elements. Start to the end. Okay, then what should happen? Tell me. Where the mid should be lying? Mid should be lying at this particular area. Am I fine? Am I cutting on to that part? No, mid would be residing here. Yeah, mid would be residing here. Then tell me what is happening. Start to the mid, this is sorted, and mid plus 1 to the end, this is unsorted for us, correct? So where the where the maximum element can reside? Into the unsorted zone. The unsorted zone is the result of presence of the maximum element, because afterwards there is a decreasing trend and then again there is an increasing trend. So due to the breakpoint here, I can say that into the unsorted region, which is the breakpoint which is happening due to the maximum element, right? The unsorted nature arises. So wherever the unsorted region is, I'm going to go on and search there. So I'm left off with 11, 12, 4, and 5. Correct? This is my new start. This is my end. Correct? Then my midpoints here. Again, you see 11 to 12, 4 to 5. Both are sorted region for us, wherever the mid is pointing. Is this the maximum element I am getting? Tell me, all of you. Whenever the mid will be pointing to the max element from start to the mid, this will also be sorted, increasing, and mid plus 1 to end, this will also be increasing, right? Because the region, both the regions is no more having, is different. The lefter and righter region both are isolated from each other. There is no more decreasing trend. Whenever I get such scenarios where start to the mid, this is also increasing, mid plus 1 to end, this is also increasing, I'm going to say that wherever the mid is pointing, this is the maximum element of the entire sorted rotated array. Keep on searching, keep on dividing the regions, right? Till the time there is unsorted and sorted nature of your regions. Whenever I'm getting that, wherever my current mid is pointing, such that start to the mid is also sorted, mid plus 1 to end, that is also sorted, I'm going to say that fine. This is the point where the maximum element resides. This is the point where maximum element resides. I can just say that fine. Do for one thing, whatever is the mid element, you just print it. That's going to be my answer. That's the maximum element of my overall sorted rotated array. Take another example, and let's suppose you are having 12 and post that, let that be 1, 2, 3, 4, 5. This is my given array, let's say. Okay, then from start to the mid, this is unsorted in nature. From start to the mid, this is gonna be unsorted. From mid plus 1 to the end, this is gonna be again unsorted. This is gonna be sorted, right? There is a nature of sorted and unsorted. This is the nature of sorted and unsorted into my given array, what I am able to break utilizing start, mid, and end. Okay, then where should I keep on searching? Into the unsorted zone. This unsorted zone would be containing the maximum element, right? Then what would happen? What would happen? Tell me. This region would be having the maximum element. I should keep on searching here. 12, 1, and 2. Correct? 12, 1, and 2. Then what should happen? Tell me. What should happen? New start, new end. Then what will happen? Start to the mid. I think, yeah, mid would be residing here. Start to the mid. This is unsorted. Mid plus 1 to end. Single element sorted, right? Keep on searching here. Keep on searching here. It's gonna be 12 and 1, right? Start is here, end is here. Mid will also be pointing to the start element. Start to the mid sorted. Then mid plus 1 to the end. This is also sorted. So wherever the mid is right now pointing 12, right? This is my maximum element of the given array. That's it. That's it. Nothing else. Got the point, everyone? Got the point, everyone? What if suppose the question is in generalized and they are saying that your array may or may not be sorted. Your array may or may not be sorted. Sorry, your array may or may not be rotated. Then what should I do in that case? Suppose that they have straight away given you a question like this: 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Your array may or may not be, may or may not be rotated. There is no rotation, but still the array is sorted in nature. Though this should not be the ideal case, this should not be the ideal case for us. The rotated means it has to be rotated at least once. Then only I can take a call what is the maximum element. If it is just a sorted array, I can straight away return the last element of the given array, right? I can straight away return the last element of the given array. How do I come to know this is a sorted array? Can you tell me? How do I come to know this is a sorted array? Overall, this is a sorted array.
Start less than end.
Okay, start, the element at the start is lesser than equal to the element at the end, right? Am I correct? Am I correct? This is it, right? Corresponding to any rotated sorted array, observe, your start element is always greater than the last element. Is it that? Your start element of the array would always be greater than the end element. So if the array has to be sorted, not at all rotated, correct? Then I can just say fine. If it has not been rotated, then the start element would always be lesser than equal to the last element. This is a signifier that array has not gone any rotation, so I can straight away return the last element. I know that this is gonna be the greatest element. Corresponding to any sorted rotated array, the starting element would always be greater than the ending element. Got the point, everyone? Got the point, everyone? Hello, am I audible? Are these observations clear?
Yes, sir.
Are these
But-
observations clear? Yes.
But in
go
one
ahead.
case, how to check? 1, 2, 3, 4, 5, 1.
Yeah, this is 1, 2, 3, 5, 1, right? 1, 2, 3, 4, 1.
Yeah.
This is again sorted, rotated only, I feel. Okay, you are saying that
Yes.
there should be a presence of duplicates, right? There should be a presence of duplicates. So one thing is that I can take a call like this, start to the mid. See, start to the mid is sorted, mid plus 1 to end, this is not sorted again. So here only, this is falling into the case of sorted rotated array, correct? One thing you can check is that how to take a call. Suppose that 1, 2, 3, 4, 5 is there. Start to the mid is also sorted, mid plus 1 to end. This is also sorted, right? Both of them are getting sorted. And then what is happening? There is a separate condition. So I can straight away come to the conclusion that this element is the greatest element. As per our analogy and observation, this element is the greatest element, but I have to keep a check. What if the given element at the start of the region is smaller than the end element? Smaller than the end element, right? Then I can come to the conclusion, then fine, whatever is the search space I am having, this is completely sorted. So the greatest element would definitely be the last element of the entire search space. Then only I can return that. As per the previous scenario, right, we can straight away go to the example, whatever we have taken, that okay, fine, both the regions are not at all sorted. So into the greatest region only I can find the element. That's it. I can find the respective greatest element of the sorted rotated array into the unsorted zone. So I would keep on searching towards the writer zone here. Okay. Ideally, the inside a rotated sorted array, correct? There should be at least one rotation that should be there. Fine. Then only I would be able to say that fine. The greatest element is somewhere in between, right? Not at the end. That's the thing. Is the concept clear to everyone? Please tell me that first. Concept is clear?
Yes, sir. It's clear for me.
Sorted. Let's see that where the question we can found directly. Greatest element in sorted rotated array, maximum element in a sorted rotated array. Where should we go it, by the way? Or in general, I think all of you are aware of the fact that we can have a linear search way of going for the approach, where we can just find what is the greatest element of there, and we can straight away return that, right? We can straight away do it. Don't we have any lead code version of the problem? Find the minimum, maximum. I don't think so. What about what pivot element? Pivot element. Sorted rotated array. Just a minute. Binary search. Sorted rotated array. Find pivot index. Let's see what they are able to see is there. Calculate the pivot. Okay, fine. I don't think this is the question. Okay, still we can go ahead with this particular approach, GFG1. Okay. Should I go straight away to code it, or would you like to try that on your own for this week? Tell me that. I don't think there is any practice link for this as well. Is it that? I don't think so again. Not able to see any practice link. Okay, fine. There is a practice link here, right? So what they are having is minimum number. Tell me for one thing, would you be able to do it in the upcoming week? Find minimum in rotated sorted array. How you are going to do that, by the way? Minimum in sorted rotated array. Whatever element comes after the maximum element inside the sorted rotated array, that's the minimum element. Am I correct? Whatever element comes into the sorted rotated array after the maximum element, that's the minimum element. Am I correct? After the maximum element, whatever resides, that's the minimum element. Correct? Am I correct onto that part? And if the array is already sorted, the minimum element is the first element. That's it. That's the only thing we require to go ahead for, right? Okay, then let's see. Fine. Let's go ahead with the coding part. Just one thing to be kept into the mind is minimum element is that element that resides after the maximum element, right? So if I'm able to find where the maximum element is, just the element after that, that's what I have to return, correct? Let's see, by the way. Medium it is, and anything else array that has been given. Fine. Let's go ahead and try this. So what is the start? That's going to be at 0th index. Am I correct? What is the end? What is the end? That's gonna be, let us calculate the length first of the array, and Tn equal to nums dot length. Okay, so what should be the end of my searching zone? N minus 1, correct? Okay, let's handle a corner case first. What if suppose the value of n is equal to 1? There is just a single element. Then what you are gonna do? If n equal to that of 1, then what is the minimum element of the array? Can anyone tell? What is the minimum element of the array? The only element itself, that's the minimum, that's the maximum, right? So I can straight away return nums of n minus 1 or nums of 0, whatever it is, whatever we are having. Let's see the constraints once. Yeah, there would be at least a single element into my given array, correct? That can be a corner case. I handled that initially. What should I do next? What should I do next? Tell me. How should I keep on searching? While start is lesser than equal to n. Till the time there is at least a single element, keep on searching and check where, what particular scenario is fitting into our finding, whatever result we are trying to find, right? Okay, what should I do? Can anyone try suggesting? What should I do right now? Start is lesser than equal to end. So I'm going to say that, should this be the case? All of you agree with me? Should this be the case? Start is lesser than equal to end. Suppose that I am trying to figure out whether the given search zone in between start to the end, whether that can be separated into two sorted zones or not, sorted and unsorted, correct? Sorted and unsorted. So definitely in order to have two regions, right, I should have at least two elements. Then only I can conclude that, okay, given region can be broken into two regions, and I can try locating wherever my minimum or maximum element resides, right? Okay. Let's do one thing. So for that, in order to have at least two elements, start should be lesser than end, right? Okay, that's what I did. What else should I do in that case? Tell me. Now what should I go ahead for? Let's try to calculate the mid. It's going to be start plus end divided by 2. Now tell me, what should I do on from here? How would you go ahead? How would you go ahead? If suppose both the regions are sorted, sorted, that means whatever is my nums of start, this is lesser than equal to nums of mid and end. What else? Along with this condition, what should I check? Both the regions are sorted, let's say. Along with nums of mid plus 1 is lesser than equal to nums of end, whatever we are having, right? Both the regions are sorted, let's say. Then what should I do? Both the regions right now, wherever I am standing, this is sorted. Then what should I do? What should I do? See, for one thing, what scenarios can arrive at this particular position? Suppose that from start to the end, 1, 2, 3, 4, 5. Wherever you are standing, the entire region of elements in between start to the end, this is sorted completely. Correct? So the start of this region should be returned as the minimum element. Or you may arrive that right now, wherever my mid is pointing, that is the maximum element of the sorted rotated array. That means 5, 6, 1, 2. Let's say into these two regions, the overall zones have got broken up. This is also sorted. This is also sorted. Correct? So one thing that needs to be taken care of, if you are trying to break like this, start to mid is also sorted, mid plus 1 to end, this is also sorted. Both of the regions are sorted for us, correct? Both the regions have got sorted, but here the entire zone is sorted for us. The entire region has got sorted. Then what should I do? From start to end, everything is sorted. How can I just check that? Nums of start is lesser than equal to nums of mid, and then nums of mid plus 1 is lesser than equal to nums of end. Then what should I do here? Two checks I require to do. If suppose, definitely I have got into a answer returning zone, right? From here onwards, I can try returning an answer. So I can just say int index, that's going to be initially -1, let's say. That no answer, I'm able to find out at what index the required element is residing. Do they want us to? Okay, no, they want us to return the proper element, right? Okay, fine. One observation is that this region sorted, right? So if suppose nums of mid, wherever we are standing, this is also lesser than equal to nums of mid plus 1, correct? This indicates that the entire region is sorted from start to end. Entire region is sorted from start is lesser than equal to mid, that's also sure, and mid plus 1 to end, that's also sure. If both the scenarios are true, then I have to just check what the scenario is actually pointing to. The mid element, if the mid element is lesser than equal to mid plus 1, then definitely the entire region in between start to end, this is getting sorted. What I have to do, I have to say that index would be equal to the sort of the minimum element that I can come here is equal to that of wherever my start resides, and I can break from here. No need to check it further. Else I know that if this is not the scene, the mid element is not lesser than equal to mid plus 1. The first scenario is not getting satisfied. Then the second scenario is getting satisfied. That I am right now, my mid is pointing to the greatest element of the entire region, right? My mid is pointing to the greatest element of the entire region. So I have to just say that how to go ahead for this. I can just say that fine. Index would be equal to that of mid plus 1, correct? If mid is the largest element, the next element to that would be the smallest element. So I would just assign my index to mid plus 1, and after either of the operation, I'm going to break. That no need to search out further. I got my required answer, right? Okay, else in what particular region the smallest element resides? Or even if you try locating the greatest element, in what particular region it would be residing. Let me say that I am interested to find out the maximum element of the sorted rotated array, because if I am able to locate the maximum element, the next element is the smallest element, right? That's what I require, nothing else. So I can just say that let's go ahead with the maximum finding approach only. So I will just say that fine. Else if both the conditions are not true, either of them would be sorted, right? Else if nums of start is lesser than equal to nums of mid. If this is the scenario that start is lesser than equal to mid, correct? This region is sorted for us. Then definitely I have to keep on searching towards the unsorted zone wherever the maximum element can reside. So I'm gonna just say shift your start to mid plus 1. That's it. Else there is just a single case. What is that? Shift your end to mid minus 1. That's it. Shift your end to mid minus 1. Should that be the case? I don't think so. Okay, fine. Shift your end to mid, right? Why I am shifting my end to mid right now? Can you tell me? Shift your end to mid. Why I'm doing that? Can anyone tell? Suppose that you are standing at 3 cases have arrived. The first one we already we have seen right now. Let that be 4, 5, then 1, 2, 3. Or let's suppose let this be 5, 6, and let that be 1, 2, 3, 4. 5, 6, and let that be 1, 2, 3, 4. Then what's gonna happen in this case? 5, 6, and let there be 1, 2, 3, 4. This is my array. This region is unsorted. This region is sorted. Greatest element resides here. Greatest element is residing here, correct? And fine. This condition is not true. This condition is true, correct? So I'm gonna just say the entire region of unsorted nature is from start to the mid. So do for one thing, check for the maximum element, whatever we are having, into the current start to the mid. So I will shift my end to the mid. I cannot leave this element 1. This is a part of my unsorted region, right? And this is entirely a sorted region, whatever I'm checking for. So in such cases, you have to go ahead and say find wherever the mid is pointing, go and try shifting your end there, not to mid minus 1. Okay. That's the thing. And at the end, whatever is kept into my index, I can just try returning it, nums of index. Return that. That's it. Try running it. Let's see whether we are getting the result or not. Okay, accepted. Let me try running it. If any corner case. Okay, it got accepted. Any doubts? Any doubts? Any doubts how to do it? Try locating the maximum element of the sorted rotated array. Correct? Try locating where the maximum element can reside, definitely into the unsorted zone of my current start to the end. Correct? Okay, if suppose both the regions are getting to be sorted, two conditions, the entire region may be sorted from start to the mid, correct? So if both the regions are getting sorted, definitely this if condition is true, then what I have to say is that nums of mid is lesser than equal to nums of mid plus 1. If this is also true, then the entire region is sorted. For sure that is so. I'm going to straight away assign my index at the minimum value would be at the start, and then I'm going to break. Else, I know that there can be just another case. What is that? If the entire both the regions are sorted, then my mid is pointing to the greatest element. Assign your index to mid plus 1, because if right now mid is at the maximum element, right, its next element would be the minimum. Assign your index to mid plus 1 and just break out from here. That's it. Correct. No more checkings required afterwards. And right now, if this is not the scene, you are getting that one is sorted, one is another one is unsorted. I would just go on and try locating where the maximum element would be residing. Because if I find the maximum element, next element is the minimum one. If suppose the first region is sorted, I'm gonna go to the right side for the unsorted nature. And if suppose the first region is unsorted, right, start to the mid is unsorted. So shift your end to mid, that the last point of contact would be mid, correct, from start to the mid. At the end, whatever the index is, at whatever value the index is pointing, nums of index, you just return that. Okay, is it clear to everyone? Please tell me. Is it clear to everyone? Again, repeated division of the search space into halves. leading me to a time complexity of big O of log n. That's it, not more than that. Again and again, you are shifting your start and end around the mid of the region, correct? Till the time I'm left with at least two elements here right now. Okay. That's the last point of searching for me. Any doubts, anyone? Any doubts, anyone? And in this case, one thing to keep ponder upon, your index would never be -1 for an array, whatever maybe the elements are, right? There would be definitely a smallest element. Even if everything is same, definitely the current element, the either of the element would be smallest. So there definitely exists an answer. Is this problem clear to everyone? Tell me.
Yes, sir.
Okay, all of you can do it. All of you can do it after the class. All of you can do it or not? Tell me. Okay. Wish to take more problems today? Hello. Wish to take more?
Yes, we can, sir.
All of you. I want all of you.
Yes.
Okay, fine. Let's go with the last problem today. What is that? Aggressive cows. Let's take that. Cows lead code, whether that's here or not, it's there. Yeah, hopefully. This is the problem of Spoj, and that is very famous problem. Okay, I don't feel there is a problem link here. Aggressive cows, okay, description. Magnetic force between two bulls. Let it be. Okay, fine. Let me find out where the aggressive cows problems are. Lead code, let's move on from the lead code to something else. Aggressive cows. Yeah, here it is. So given an array consisting of n integers which denote position of the stalls, right? You are given an integer k which denotes the number of cows. K number of cows needs to be placed in n stalls that has been given to you. What are the positioning? Imagine a straight line from 0 to infinite, and in between them, in between 0 to infinite, there are integer positioning of n stalls that has been given to you. Now the point is, you are given the task of assigning the k cows such that the minimum distance between any two of them is maximized. Okay, any two of the cows should be placed at as maximum possible distance as possible. Okay. Let's see what the question basically means here. And we are having stalls 1, 2, 4, 8, 9 and n and k, correct? 1, 2, 4, 8, 9, right? These are the positionings of my stall, k equal to 3. 3 cows needs to be placed here, correct? Okay, then. And number of stalls are 5, what is already being given. Now, at what positioning, at what particular points you wish to keep your cows separated from each other? At what particular stalls you wish to keep your cows? What are your thoughts? 3 cows needs to be placed. Okay, what if I say place cow 1, cow 2 and cow 3 at these particular positions at stall number 1, 2 and 4? Then in between any two cows, what is the minimum distance we are getting? In between any two cows, what is the minimum distance we are getting? Between cow 1 and cow 2, we are having a distance of single unit. Am I correct? This is the minimum distance that is possible. Okay. And between cow 2 and cow 3, the distance is 2 units. Correct? So this is my answer. The minimum distance between any two cow is 1 unit. Correct? Now, if I ask you, can the minimum distance between any two cows be maximized beyond 1? Is it possible? Asking you for this thing, can the minimum distance between any two cows be maximized beyond 1? What are your thoughts onto that? Tell me. 1, 2, 4, 8, 9. So if I am saying that let's cow 1 be placed here, let cow 2 be placed here, let cow 3 be placed here, then can I say the minimum distance between cow 1 and cow 2 is 3? Cow 2 and cow 1 and cow 2 would be 3, cow 2 and cow 3 would be 5. Stall number 9 and 5 are separated by 5 units of distance. Cow 2 and cow 3 are separated. Cow 2 and cow 1 are separated by 3 units of distance. Previous example, previous placing, whatever I did, Based on that, the minimum distance between any two cows is 1 unit, and here it is 3 units. So this is a better answer. I am able to maximize the distance, the minimum distance between any two cows. Got the point here? What the question is trying to say? All of you got the point? The minimum distance between C1 to CK, the minimum distance between any two cows, you have to maximize it. Based on the availability of stalls, I have to keep any two cow as farther as possible, correct? So that in between any two cows, if there is the minimum distance, that would be getting maximized. Correct? Now my point is how you're gonna go ahead and try this. Any thoughts on the problem? Any thoughts? Tell me, all of you. Any thoughts? Anyone? Tell me. What should I do? Okay, try thinking of a space to search for. If I'm saying is that now you have to maximize the distance between any two cows that's possible, as maximum as possible. What can be? You're having 12459, I guess, right? 12459, or yeah, or let's suppose 12479. This is the stall number, and 3 cows needs to be placed here. Okay. Now, what is the maximum distance that is possible between any two cows? Can anyone tell? Between any two cows, what can be the maximum distance that's possible? Tell me that. Can I say any two cows can have the maximum distance once they are placed in the first and the last stall? Am I correct? So the maximum distance can be 8. Minimum distance between any two cows, all are placed into the same stall. All are placed into the same stall, correct? So my search space is in between 0 to 8 units of distance. Now I am going to try that. Let me go to the mid. Let me go to the mid of the region and try whether any two cow can be placed at least at a distance of 4 units of not. Okay, 4 units or not. I would try placing cow number X and cow number X plus 1, whatever I'm trying to place, at least separated by 4 units of distance. That's what I am going to try out. Correct? Let's try that. Okay, 12479. Sorry, 12479. Okay, fine. Let's suppose I can, without any hesitation, I can try placing my cow number 1 at the first stall. Okay, so that all other leftover stalls that are farther from here can be placed at the rest over distances. Okay, let's try placing my cow 2. Tell me for one thing, if you're trying to place cow 2 at stall number 2, is it going feasible? Is the distance between cow 2 and cow 1 going at least 4 units? Tell me that. Is it happening? No, right? 2 minus 1. The distance between stall 2 and stall 1, where I'm placing my cow 1 and cow 2, this is 1 unit, right? So it is smaller than 4 units. At least 4 units of distance should be maintained between any two cows. So this is not the choice for cow 2. What about cow 2 at stall number 4? The distance here is 3 units. Not possible. Okay, fine. What about cow 2 at stall number 7? I can definitely place it. This distance between stall number 7 and stall number 1 is 6 units. Minimum required was 4 units. I am able to place that at a greater distance, so acceptable. What about cow number 3? Only one stall is possible for cow number 3 for us, right? That is 9. What about cow 3? If it is placed at stall number 9, then definitely the distance between the previous cow and the current cow is 2 units. I am unable to do it because it has to be at least 4 units as per what my mid is pointing to. So as per, if I say that 4 is the minimum distance between any two cows that I am employing right now, cow 3 cannot be placed at any of the stalls. At any of the stalls, cow 3 cannot be placed. So let me minimize the distance a little bit. Let me say that fine, 0 to, in between 0 to 3, right? Let the search space be in between 0 to 3. And because 4 has failed our solution, with taking 4 as my possible solution, I'm unable to place all the cows. All has to be placed. So definitely, if I try to again maximize towards the right region 5, 6, 7 for further greater units of distances between cows, these stalls are gonna fail only. Okay, the cows are gonna get farther apart, and if farther the cows, then definitely all the cows cannot be placed. The minimum distance has failed, so the maximum distances beyond this, the greater distances beyond 4 are bound to fail from here, right? I'm left with 0 and 3. So I am saying that 0 to 1, this mid would be corresponding to 1 unit of distance. And again, the stall numbering remains same. Right now, cow 1 without any hesitation can be placed at the first stall. Cow 2 can be placed at the second stall. Minimum distance allowed between any two is 1. So cow, it is suitable for me to place cow 2 at the second stall. Cow 3, I can safely place at stall number 4. I am, because between cow 2 and cow 3 that are closest to each other, the distance is 2 units more than the required one. Definitely, if I'm trying to place, the cows at a distance of at least 1 units, right? Then the answer is sufficing. That the answer can be for me 1 unit of distance. One of the possible solutions I have got here. Then I'm gonna say, okay, if 1 unit of distance in between any two cows has satisfied, why not to try increasing that? Okay. Why? What if at a greater distance of 2 units, at a greater distance of 1 unit, I am able to separate cows? What if that is possible? So my search space would be going towards the right in between 2 and 3. Start points here, mid will also be pointing here. Mid will also be pointing here. Again, the stall numbers remain same, 1, 2, 4, 7, 9. So here, cow 1 without any hesitation, at least 2 units of distance between any two cows, cow 2 cannot be placed here. Cow 2 can be placed here because distance between cow 1 and cow 2 would be right now 3 units. What about cow 3? Cow 3 can be placed at the third stall, right? Cow 3 can be placed at the third stall. Sorry, at the fourth stall. That is that stall number 7. Distance between any two cows are going to be at least 2 units. That's satisfying. That's getting satisfied. So I'm going to say at a greater distance of 2 units, all the cows can be separated. So I updated my answer. So I can say, okay, try the last value available into the search space. That is 3, correct? So mid, start, and everything would be pointing here only. 1, 2, 4, 7, 9. 3 units should be there, the distance between any two cows. Again, I think cow 1 can be placed here, cow 2 can be placed here, cow 3 can also be placed here. So at the end, all the cows have been successfully placed. Fine. And I can say that, okay, 3, at a greatest distance of 3 units between any two cows, I can place them into the given stalls, and the answer would be updated to 3. So 3 is the maximum distance. What we are getting as per the possible choices. The distance between any two cows, right, that can be separated from each other is at least 3 units. You have to make a space to search. Minimum distance possible is 0, maximum is 1 minus 9, 8. In between all these values, what is the maximum value I can get into the search space, such that based on that value, the distance between any two cows, right, is at least that value. Let that be X. This is the maximum value into the search space from 0 to 8. And the distance between any two cows is at least X. That's what we have found, correct? And this X in our case turned out to be 3. So that's the answer we got. Is the approach clear to all of you? Is the approach clear to all of you? How to go ahead and try that? Is that
Yes, we can try. Actually, same kind of problem approached by Wednesday by Amir.
Amir, right? Okay, then.
Yeah.
Okay, I have given you the idea, right? For aggressive cows, please try that. If you are unable to do it, we can take the coding part, and once again, we can have the revision in the next day, next Saturday. Works?
Yeah.
Works for everyone?
Yes, sir.
Okay, please go ahead, and few more problems on similar lines we are going to do, and we can wrap up the binary search topic. Okay? Works for everyone? Please tell me.
Yes.
Okay, so 3 problems we have seen today, right? Coding of search in sorted rotated array, minimum element is sorted rotated array, and what else? The aggressive cows problem, correct?
Yes. In the
let's take-
array of stalls, it should be in sorted manner, right?
No, even if it is not sorted, you have to sort that separately. Okay, check the examples whether that's sorted or not. If it is not so, you have to sort it separately.
But the approach will work only in
Yeah,
sorted manner.
yeah, exactly. So into the stalls can be given in non-sorted manner as well. So you have to sort it separately. Okay,
Yes, sir.
that has to be there. Any other doubts you have for today's session? Tell me that.